Hello everyone, my name is Tobias. I'm here to talk to you a bit about Project Syn. I want to introduce it to you. And yeah, I work at Vision. I'm a big fan of Kubernetes. You might see that on my t-shirt. I was at KubeCon last year. Sadly, it didn't work out this year, but who knows how it looks like next year. But you've seen Kubernetes before on this Windows desktop. It was a single node Kubernetes cluster. But now we want to talk about a fleet of Kubernetes clusters. And we will see how Project Syn can help you here. You might wonder, why Project Syn? Well, what's the name behind it? And my company is good in naming. So we've chosen also a good name for this project, and at least Syn can be used in different constellations like synthesize, synfection, or whatever you can imagine doing with this word. So, but the main idea was if you translate this from Swedish to another language, it's just Vision. So Project Syn is an integrated set of tools which helps you managing a fleet of Kubernetes cluster, and we will see in the next few slides what this means actually. So why do we even need such a thing like Project Syn? So if you ever had to manage a huge amount of Kubernetes clusters, like hundreds, then you might know it's not that easy to keep track on what's going on so many clusters. And we thought, why not automate that? Because that's what we do all day. Some questions you might ask yourself if you manage an amount of Kubernetes clusters. So for example, where are all my clusters? And to whom do they belong? They might belong to a customer, to a team, or whatever. They might be in the cloud or on your desktop or wherever else. You might have very many different Kubernetes flavors around, like EKS, AKS, OpenShift, Rancher Kubernetes, whatever. And you want to know which one of your Kubernetes cluster has which flavor, for example. Then how do you bring configuration onto your Kubernetes clusters? That's mainly the same issue you have when you manage a huge amount of Linux servers. You also have to somehow want to manage them all the same way. And how can I have a common configuration across all my Kubernetes clusters? Also the same questions you might have managing a fleet of Linux servers, like setting the NTP server on all my Linux servers to the same value. And more like a philosophical question, what actually does managed mean for a Kubernetes cluster? So Project Syn tries to bring answer to all these questions and help you to solve these problems you might have. Let's dive into a list of features which Project Syn has today. So first and foremost is the multi-tenant and multi-cluster management feature. So it's actually the inventory of your Kubernetes cluster. So it knows where they are, to whom they belong, what kind of Kubernetes clusters they are, and so on, and brings the initial automation stuff you need to manage all these Kubernetes clusters. Then it brings, of course, GitOps. That's the buzzword of the day. So Project Syn helps with the full automation around GitOps. And it uses as a main tool Argo CD to apply configuration onto your Kubernetes clusters. It also helps to actually make a Kubernetes cluster Project Syn managed. So you can compare this to install the Chef agent in your Linux server, install the Puppet agent in your Linux server, and so on. And as soon as you have this agent installed, the server gets automatically managed. And the same here, as soon as you install the agent of Project Syn in your Kubernetes cluster, it automatically gets managed by the tooling around it. And it tries to do that in a securely fashion so that you cannot install the agent in a cluster which you don't have access to. Then it helps you with configuration management. So as it knows all about your Kubernetes clusters, where they are, to whom they belong, and so on, it tries to give you tooling to distribute configuration, generate configuration, depending on the flavor or on the location of a Kubernetes cluster. And it does this by using a hierarchical configuration structure. So many of you might know Puppet, and with the hierarchical configuration backend, it has a similar approach to this. Also, it brings reusable components, so we think it doesn't make sense to write such configuration management for, let's say, the Nginx ingress, the metric server, and so on, again and again. So it's a component-based, which can be reused by several different Kubernetes clusters and users of the project. Also, the project itself brings a default toolset. That means it also already brings a huge catalog of such reusable components with it. Also, these components, they are automatically maintained by Renovate. That's a bot which tracks upstream versions of tooling and makes sure that all these components are using up-to-date software. Another issue what you might have when you're working with Kubernetes clusters, how you securely manage your secrets on a cluster. And Project Syn helps you here as well by leveraging HashiCorp Vault and Kapitan as the configuration generator in the backend. So, but how does this all work? That was a lot of buzzwords and a feature introduction and so on. And yeah, I'm sure you want to know how it actually works and what it looks like in practice. So here is a picture, an architecture picture, which you can also find online if you want to study it in detail. So important is that the blue boxes on this diagram are tools which are developed in Project Syn. The green boxes are Git repositories which store information, different kind of information, and the white boxes are upstream tools which are in use here. So the most important component here is the Lieutenant. That's the inventory API which stores all the information about your Kubernetes clusters. And it also takes care of managing Git repositories at this time in GitLab, but it could also do this in GitHub or in GT or other Git hosting repository software. Then we have Commodore. Commodore is the configuration generator. This tool uses Kapitan in the backend to actually do the hard work, and it is mainly a wrapper around it. It connects to Lieutenant, collects all the information about the cluster, feeds this information into Kapitan, and then generates configuration files. These configuration files are then stored in a Git repository per cluster. So each Kubernetes cluster has its own Git repository storing all the YAML files which are actually generated for this particular Kubernetes cluster. On the cluster itself, we have Argo CD running. Argo CD will then fetch these YAML files and apply it to the cluster and make sure this configuration is available. Inside of the cluster, we have the steward. Steward is the in-cluster agent which enables Project Syn on a cluster. It's the bootstrapping tooling and also the babysitting tooling. It makes sure that Argo CD is always up and running. It has the correct configuration. And Argo CD on the other way around checks that Steward is up and running and has the correct configuration. Initially, when the cluster isn't managed by Project Syn, Steward will bootstrap Argo CD into the cluster, generates access secrets for the cluster catalog repository, and together with Lieutenant, make sure that the whole bootstrapping process is completely automated and you don't have to touch anything anymore. On the Git repository side, we have the common configuration Git repository. This holds configuration settings for all your Kubernetes clusters which are managed by this instance of Project Syn. Then you have another Git repository which stores information per tenant. That can be, as already told, a customer, a team, or a sub-team, or whatever you want to have as a tenant. And this Git repository stores the common configuration per tenant, but can also store configuration per cluster if you need that. And as you see, we also have Renovate, watching these repositories, making merge or pull requests whenever needed to update versions. And we have these Commodore components, which are stored on GitHub and can be used by the community. Also, we have Vault in the middle. Vault is used to store secrets securely. It is used by Kapitan in the backend to retrieve secrets and to apply them directly on the cluster if needed. So that means no secrets are stored in Git, actually. In Git, we only store references to secrets. We not even store encrypted secrets. It's just references. And during the phase of apply on the cluster, the plugin in Argo CD for Kapitan knows what to do with these references and retrieves them and applies them directly in the cluster without revealing them outside of a cluster. So secrets are completely contained in a Kubernetes cluster. Another deeper look into the operator, that's the lieutenant you have seen in the picture before. The lieutenant operator is there to implement automation as much as possible. So for example, if I register a new tenant, the operator automatically connects to, for example, GitLab and creates a Git repository and prepares this Git repository for later use. The same happens if you register a new cluster in Lieutenant. The operator automatically creates a Git repository for this cluster, which is then later used to store the catalog of all the YAML manifests to be applied on the cluster. It also takes care of, for example, configuring deploy keys on the Git repository. So you don't have to manually create the Git repository and grant access and all these things. This is all handled by the Lieutenant operator. To access all this information, you can either use directly Kubernetes API possibilities, or there is a lightweight layer in between. That's the Lieutenant API. That's a RESTful API which allows for easy access to tenant and cluster objects to have an easier means of developing against this tooling. The core Project Syn tools are, as you have seen in the diagram, are the Lieutenant API, the Lieutenant operator, Commodore, and Steward. These are the main tools which are being developed in Project Syn. And we also use a lot of third-party tooling. For example, Argo CD. Without Argo CD, the whole process wouldn't work. Also, Vault is very important to store secrets in a secure fashion. And Kapitan is used to do the hard work for generating actually the configuration. We are also using Renovate, and we are experimenting with Crossplane for automated service provisioning in the cloud, but that's just in the experimental phase at this time. So now we have seen an overview of the concept behind Project Syn. And now we can have a bit deeper look into what's going on behind the scenes. First and foremost, the most important part of Commodore is the configuration hierarchy. So that means you have a possibility to define common parameters which are the same on all your clusters. And then, depending on the hierarchy, which is defined currently in the code, which can be configured in a later stage, you can override configuration parameters or add additional configuration parameters depending on the specs of your Kubernetes cluster. So as you see, the deeper you go into the hierarchy, the more specific the configuration is. So you're able to override on a tenant level, on a cluster level, or on a cloud provider level, depending on your needs. And this helps to have a common configuration across all your Kubernetes cluster, but also have a common configuration per customer or per cluster. This hierarchy is currently hard-coded. We are working on a feature to make this configurable at the end. So how does such a common configuration repository look like? You can browse to GitHub and have a look on your own. This is a Git repository consisting of several configuration files. And one of the currently most important file there is the Commodore.yml. This specifies where all these components are stored. So you can store components on your internal Git repository hosting, or you can store it on GitHub. And with this file, you actually specify where these components can be found. So that during the phase of compilation, the tooling knows where to fetch these components. Then an example here, it's a bit small, but you can see it on GitHub as well. You see here, for example, a definition for a K3s Kubernetes cluster. And this one includes, for example, Argo CD and the metric servers. But with this definition, you could also include other components as well, if you want. Then you can set parameters per component. For example, here you see we configured the API URL on the steward cluster, and this is now on the part where we can override parameters. So maybe you have a common configuration which says, hey, Lieutenant is available here, but for this particular cluster, it's available on a different place. How does such a Commodore component look like? It's mainly using the Kapitan configuration structure, so it might be a good thing to know how Kapitan works, and this also helps to understand Commodore much better. Commodore has a defaults file. This is here. This one specifies the default parameters for this particular component, which is used by the hierarchy on the top level. Then you specify some parameters for Kapitan itself. This is the my component file here, and then as you see on the file ending, it's a JSONnet component. But Kapitan also supports Helm charts, for example. So if you already have a good Helm chart for your thing you want to install, you could also use a Helm chart and just parameterize it using Commodore. But we started to use JSONnet a lot. It helps you with a good amount of flexibility of developing such components. So that was a very quick introduction to the project itself. Usually you learn a lot when you do it yourself, not just by listening to some slides and stuff. So we wrote the Getting Started guide, which you can do on your own. It's a step-by-step guide. When you have done this, you have a full Project Syn instance up and running. It takes you around half an hour, I would say. And if you want to dive deeper, there is a whole lot of documentation already available. We wrote the full tutorial of how to write the Commodore component, because in the day-to-day business of managing Kubernetes clusters, most of the work goes into writing, adapting, and enhancing such Commodore components. We are currently at version 0.2. We are using it internally for a few initial test clusters, also a few production clusters, as usual. Usually tests goes into production much faster than you think. But you're gaining experience with this tooling all day, and this also gives us a good input for the roadmap. And you can also see the roadmap on the website and see where you want to head. It's on GitHub. It's in its own Git organization. We want to open this project to outside contributors, so it would be cool to get some more help here. That was a short rush through Project Syn. If you have any questions, I'm happy to answer them, but we are also reachable on email. We have a chat channel, and yeah, that's it. Are there already any questions? Yeah.
So I'm guessing you started building this before Kubernetes, so more or less you are competing with Rancher.
No. So the question was if we are competing with Rancher?
No, basically, if I would choose to build like a cluster fleet management, such as, let's say, multiple clusters being managed by one single cluster,
Yeah.
why would I use Project Syn versus Rancher, which exists for already a couple of years? Right?
Okay. So the question was, why should I use Project Syn instead of Rancher?
Yeah.
So Project Syn focuses on configuration management. It focuses on assigning clusters to tenants. It focuses on an inventory service which brings you much more information than Rancher. It doesn't compete, it enhances Rancher. We are also using Rancher internally for managing Kubernetes clusters. We use it to spin up Kubernetes clusters, spin down, monitor them, and so on. But we use Project Syn to actually deliver configuration to many clusters, which are much more powerful than what Rancher can do today.
But then you don't manage user access with Project Syn, do you?
No. So the question was if we manage user access to the Kubernetes clusters. No, this is done by Rancher. Okay. Yes. Yeah. Any other questions?
When did you start working on Project Syn?
So the idea is about 1.5 years old, and actually the development or the research started in November last year, I would say, and actually the development part started in February this year.
Yeah, and it's the last chance to ask some questions here in the chat. So if you have any questions from the audience remote, please write in the chat. Here, Tim, how do you get your existing clusters into Syn?
Okay, so how do we get our existing clusters into Syn? So we register them in Lieutenant, so we make them aware. We make Lieutenant aware of the cluster, and then we apply steward to the cluster. That's okay. When you register a cluster in Lieutenant, it automatically generates an apply URL for you, which includes a short-lived secret. So the output of the register command is that you get a kubectl apply -f URL, and if you do that, it installs steward, and it knows already all about where the catalog repository is. It knows all about how to bootstrap Argo CD, and then magic happens in the end. Good?
So thank you very much for listening, and if you have any feedback on improving our streaming setup, please approach me. So there was one minor issue with the sync of the stream, so I restarted it and it worked.
Okay.
So,
cool.
Okay, thank you. Then goodbye.
Thank you.